So that is an ought apomorph. Whereas if we look at the presence of hair, the ability to produce milk, well, that among mammals, those among mammals are syn apomorphs, because these are shared derived characters. Every single group of mammals share that derived character. Why is it derived? Well, our reptilian ancestors didn't produce milk and they didn't have hair. Okay, so these are shared. And what's the best word I can use for ought apomorph? Yeah, maybe. I'll put that in quotes. But unique sort of hits it because it's the only group, only one group would have that characteristic. Right? So the syn part here means shared or same. So a cladist will look at traits and try to define what's primitive and what's derived. And then it'll look at the various groups under consideration and determine whether things that are present, characteristics that are present, are ought apomorphs or whether they are syn apomorphs. Right. All other things being equal, groups with a large number of synapomorphies are more closely related than individuals that do not share those traits. So we're talking about traits through time. If a large number of different groups share a synapomorphy, or even a small number, we're going to assume that they are more closely related than a group that has only ought apomorphs or does not share those synapomorphs at all. I'm going to give you an example here in a minute. Yeah, I can do that. That's memology. Word handouts. Okay, handout 5 in the lower left. Handout. Everybody got one? Probably don't have the last one. Okay, so 5 in the lower left. This is just a diagrammatic representation of what a cladist would do. And it's nebulous because it's just illustrating using letters. So rather than talking about specific traits, we're just using letters. Handout 5, lower left. So you can see at the bottom, we're starting off with 4 traits, M, N, O, P, and Q. Those are the ancestral traits. And then we're going to try to classify our different groups, A, B, C, D, and E. Right? So we have 4 groups of animals, and we want to see how closely they are related to each other. Well, the first thing that happens is that we see that in one group, we get a derived condition. So a new condition forming an N in Q. They're using the prime to indicate a new characteristic. Right? And then a double prime is going to be even more advanced. So we have an advanced N and an advanced Q on the left side of the diagram, but all of the organisms on the right only have the advanced M. They do not share with the animals in A and B. They do not share the advanced trait N and the advanced trait Q. Right? So we're grouping all the A's and B's together because they have the shared N and the shared Q. C, D, and E are going to get group together because they have the shared M. Right? These are shared derived characters. And then are A and B, let's say, in the same species? Well, when you look at B, it still has, of course, its N and Q, the advanced N and Q, but B evolved an advanced version of P, whereas A does not have that. So that is why we split them into two different groups. They do not share that advanced trait. So the other way to look at it is we're grouping them together if they do share the advanced trait. So A and B, why are they grouped together? Because they have advanced N and they have advanced Q. If you look at C, D, and E, they're going to differ from each other a little bit. So that C up there has the advanced version of P. But D and E do not have the advanced version of P. Instead, they're going to a more advanced version of M, so double prime on the M. So D and E share the synapomorphy, the advanced trait of M double prime, but they share, C and D as a group, share with C the advanced form of M. So C, D, and E get put together. But then they have particular traits that set them off. Right? So C had the advanced P, D and E did not. D and E get put into different groups because O has a derived characteristic that differs from D. E has the advanced version of O. So clades are going to combine groups that share synapomorphies into a single group or a single clade. So D and E form a particular clade. They both have the advanced, double advanced version of M. C, D, and E, well, that's a clade as well. All right? And they're all together because they share that advanced M. All of those animals, A, B, C, D, and E, are a clade as well, all right, just a little higher up the chain, because each of them has some version of M, N, O, P, or Q. Okay. So clades may use their techniques to put things into species. So perhaps we say that A and B are species and they belong into a particular genus, and we could give them names. C, D, and E. Well, D and E could be separate species that we put into a particular genus, but C is going to have to be off by itself in another genus because it doesn't share some of those traits with D and E.